Hello everyone and welcome back to my channel Lessons from Asha. Till now we explore that charges do exist within the matter, and we also saw how objects can be electrically charged. We also came across how Coulomb studied these electrostatic interactions. Now we can move on from basic observations to mathematics. So today we will try to derive and understand what is Coulomb's law, which is one of the most fundamental laws of electrostatics. We will also try to interpret it physically instead of just memorizing it. So shall we begin?
After many careful experiments with charged objects, Coulomb observed a remarkable pattern. The electric force depended mainly on two things: the amount of charge and the distance between the charges. Today, let us convert those observations into mathematics. Coulomb observed that charges exert forces on each other. Like charges repel while unlike charges attract. But an important question remained. How exactly does this force depend on charge and distance? Coulomb observed that larger charges produce stronger electric force. If the amount of charge increases, the force also increases. So the inference was force is directly proportional to the product of the two charges interacting. Hence, mathematically we can write force F is proportional to Q1 multiplied by Q2. Coulomb also observed something extremely important. As the distances between the charges increases, the force decreases rapidly. So here the inference was more specifically that the force between the interacting charges varies inversely with the square of the distance between them. This is called inverse square law. The square dependence is very important. If the distance between the charges doubles, the force becomes 1/4. If the distance triples, the force becomes 1/9. So, electric forces decreases very quickly with the distance. Combining both observations, we get force is proportional to the product of charges divided by square of the distance between them. Removing proportionality gives the complete mathematical expression of Coulomb's law. The constant K depends on the medium surrounding the charges. In vacuum, K is written as 1 upon 4 pi epsilon naught. Epsilon naught is called the permittivity of free space. It describes how the medium permits electric interactions. Electric force always acts along the line joining the two charges. This direction becomes extremely important later when we solve numerical problems involving multiple charges. Coulomb's law is not just a formula, it allows prediction. Using mathematics, we can calculate electric interactions, understand charge systems, and later study electric fields, electric potential, and many advanced concepts in electrostatics. Real objects usually contain enormous numbers of charges and not just two isolated charges. So, how do we calculate force in such situations? That is what we will explore in our next lesson using the principle of superposition.
Today we converted Coulomb's experimental observations into a mathematical law. We understood that electrical forces depends upon the magnitude of the charges interacting and also the distances between them. But in reality, charges don't exist individually in matter. There will be multiple charges which are existing together and they are acting simultaneously. So, in the next lesson, we'll try to extend this Coulomb's law to systems which contain multiple charges using the principle of superposition. So, thank you for learning with me today, and I'll see you in our next lesson.
If you found this explanation helpful, do like, share and subscribe to the channel for more simple and interesting physics concepts based on the NCERT syllabus. So see you in the next lesson. Until then, bye-bye.